Understanding electricity. What is a current? Whenever particles flow, we call it a current. The same applies for an electric current, except the particles are called electrons. So let's imagine an electron is a person, and this person is walking along a road. Just like an electron would move through a wire. The money that they carry is called kinetic energy. This determines how fast they move through the wire. Then we introduce battery man, or woman. Battery man carries donuts, and these donuts are called potential energy. This potential energy can be turned into the same kinetic energy which the electrons need to move through the wire. So battery man places 2 donuts on one side of the battery and 2 donuts on the other. These are called terminals. As soon as he does this, the electrons experience an instant force of attraction towards the donuts at the terminals, just as you would if you saw a donut on the road. The question is, which direction do the electrons travel? There's 2 donuts to the right and there's 2 donuts to the left. In the end, they can't all agree. There's no real reason to pick one end instead of the other. If the majority of electrons don't have a preferred direction, we say that there is no net current. So battery man thinks, and then he has an idea. Donut difference. With donut difference, battery man places more donuts on one side of the battery than the other. This makes it easier for the electrons to decide which way to go. This is because there's a potential difference across the 2 ends of the battery. Now this potential difference can be measured in donuts, but it's better to write volts. So the majority of electrons move towards the 4 donuts, and if the majority of electrons move in one direction, we say that there is a net current. And this is all because of the potential difference created across the ends of the battery by battery man. So battery man is a happy battery. He's realized his dream of converting potential into kinetic energy. But with every voltage, there is a resistance. And resistance is only one thing on its mind. That is to steal the kinetic energy from the electrons. So an electron will be happily bouncing around until it collides with a resistor, which can be thought of as a positive ion or atom vibrating. Then the electron leaves with less kinetic energy. Resistors come in different forms. Some are high in resistance, others are low in resistance. This depends on the temperature or material within the resistor. So when a current passes through a circuit, the resistor will slow down the current. And this is what we call Ohm's law. Potential difference is equal to current times resistance, or donut equals man times wall, whatever you prefer. So if you want to increase the resistance, the current will decrease. Or if you want to increase the current, the resistance will decrease. This all takes place if we keep the voltage or potential difference the same. So battery man thinks, if he can turn his potential into kinetic energy, well, when that kinetic energy is lost, that means his potential will be lost too. And this is what we say happens at a resistor. Rather than say kinetic energy is lost at the resistor, it's better to say potential is lost at a resistor, or that there's a potential difference. Sometimes it's called output voltage. Also, if potential can be turned into kinetic energy, well, kinetic energy can be turned into a different form of energy called light. And that's what some special resistors do. They turn kinetic energy into light, and they're called filaments. So there you have it. I hope you understand a bit more about electricity. If you have any questions, please comment below, or any suggestions for future videos. Once again, thanks for watching, and please subscribe.